Hello, welding students. Let's go ahead and talk a little bit today about the welding flange. You will need your Pipe Fitters Blue Book by V.W. Graves. You'll need that today. And sorry about the condition of this one. This one's the one that I keep in my truck, so it's nice and beat up. But nonetheless, you'll need yours today, or here these next few minutes. And we're going to talk a little bit about the flange. Let's go ahead and jump in there. Right off the bat, we're going to notice here there's way too many dimensions in here that we'll need, but still you'll be able to tell every facet about this connection with these measurements, okay? For instance, it's not important for us to know the bolt hole size, bolt hole pattern centers, but it is some information that we do have access to, and it may help you in the fit up. First of all, let's take a look at our OD here, and I'm talking about the outside diameter of the pipe. This A, of course, is our measurement that will take care of that. In this case, in our packet, we're going to be welding on 2-inch nominal 2-inch pipe, which is 2 3/8 or through 2.375 OD, and that's going to match this A dimension that we have on our flange here. This one, of course, will match several flanges, but this is a 2-inch 150 for our purposes. Okay. We're also going to know the depth from face to face, as far as the beveled end to the face end, and we'll have a measurement. Y will represent that measurement. C is a measurement from the raised face to this plane right here, which is not important for our fit up, but it is described in our book as well. The raised face area, which also doesn't concern us much, but it's also perfect for us to know the face seating area of our gaskets, whether we use a paper gasket or a flex gasket. And we'll talk about those gaskets a little later on in class. If we ever needed to make a blank or a flange or some way of covering this, we will need to know bolt centers, And let me give you an example of how the bolt is. Here's a front view of a flange. Some flanges have 4 bolts, some flanges have 8 bolts. And it goes up from there. There's several. The bigger the flanges are, of course, the more bolts are going to need. Each flange center and a bolt hole are built to specifications. So essentially, each one of these flanges will match each other. So it falls on us as the welder, as the fitter, that we need to make sure that we have these 2 holed, that we need to have them as straight as possible, so that they can match up as perfect as possible. Okay, here is another example of our seat area. This is going to be our gasket seating area. There's where it's going to be the business end of the gasket, where it's going to do its job. Some gaskets are built where they sit on top of the bolt holes and they just match perfectly with the seating area. And some flanges are like this here, where they're full face flanges and the gasket seats on every area other than the bolt hole. It just depends on the application, okay? But I wanted to show that to you, give you a front view of the flange. And if you have any questions about that, let me know. So let's return back to this one here. O is representing the outside diameter of the flange. And that is important when it comes to fitting up, making sure we have clearances, things of that nature, making sure we have a way to fasten this flange and that we make room for it. Okay, so if you'll take your book, open it up with me to page 101 and 102 in your book, and we're going to go over a couple of quick details here. Okay, if you'll look, you'll notice that we're going to be talking about 4 different flanges: a weld neck, slip-on, a threaded flange, and a lap joint flange. And if you look on the upper left hand side, you'll see that all of this information is with regard to 125-pound flanges. If you look up on the other upper right hand side, you'll know that all this information from 1/2 inch all the way to 24 inch is talking about 150 pound connections. So this will go all the way up to, and I believe on page 8, all the way up to 2,500 pound connections. So there's 25, 1,500 pounds, and all those connections, information on those connections, our takeoffs and whatnot, or you'll be finding these pages here. But for us, we know that we are dealing with a 2-inch, 150 pound flange, and we know that our welding takeoff is going to be 2.5 inches. And so I've taken the liberty of writing that off here to the side, 2.5 inches or 2.5 inches. And that's going to be our welding neck size. We also know by looking at this form here that 2-inch will require 4 3/4 inch bolts. So it's get number and size of holes. So we have 2-inch. We're going to need 4 3/4 inch bolts to fasten our connection up. Now, why do we need to know that right now? We actually don't need to know that for us to make this connection. But if you have to order parts for the job that you're doing, please keep in mind how many bolts, what size, what length you'll need to have to do that, to have this job filled up. So it may or may not fall to you, but there's information on here about that, and you'll need to be aware of that. Okay, so let's go back to our drawing here. Whenever we do have a flange fit up, let's take a look. If we were to weld a flange to flange, and this is 12 inches, then we know that we have 2.5 inches per flange. So now that's going to give us a measurement on each one of these connections, and we'll be able to 2.5. Last time I checked that, it's going to equal 5 inches, and we're going to know 12 minus 5 equals 7 inches. So we're looking at a 7-inch pup length there, and that's how we're going to do that. So our flange is very important. Let's go back to another little section of our flange that I think is very important. If you'll notice right here, most factory flanges are going to come in a 37-degree bevel angle. That's pretty standard. In our business, we know 32 to 37 degrees is pretty normal for our standard. But what we do want to make sure, guys, is that the bevel angle on the size of pipe that we're going to weld over here is of the same angle. We do not want a lopsided angle. We don't want this narrower and this one wider. It's going to make for an uneven weld, and we're going to have problems there. So make sure when we weld these up that these bevel angles match up. Okay? And in the meantime, until we get used to it, we need to measure those. Do not trust your eyesight to do that, okay? No eyeballing stuff here. Let's measure them correctly. First, and then the other thing we need to talk about is pipe schedule. That's going to be determined by the bore. The flange is the measurement inside is called a bore. Inside of our 2-inch pipe, we're going to call that wall thickness. So if we have a 2-inch schedule 40, we have a certain wall thickness. 2-inch schedule 80, we have a wall thickness. With regards to our flanges, we're either going to have a standard bore or an extra heavy bore and things like that. Make sure that our wall thickness, which is from here to here, is going to match the carrier pipe that we'll be welding this to. So lots of small details, but something that can be actually get a hold of early. We need to know this information early before we start welding on our pieces. Our packets are just about ready for construction, and 4th semester students will need to know this information. So if you have any questions, please give me a ring. Thanks for watching the video, and we'll see you guys in the welding shop.